Hey guys, I just want to take a moment and review factoring polynomials with you. So these are the types of problems that, let's say you start with 2x plus 4, and when you factor it out, you get 2 times x plus 2. And you wonder, how in the world did I get from that to that? Well, it starts with knowing the greatest common factor. So let's say I have a group of these lovely little stars, and I've got a group of 6 here, and over here I put a group of 9. This might take a minute. So what are the even groups that I could take out? Well, I have 6 over here, but does 6 go into 9 evenly? It does not. So it has to do with what groups can I take out evenly. So it turns out it's a group of 3. I can take a group of 3 here, a group of 3 here, and then I could take a group of 3 here, and a group of 3 here, and a group of 3 here. So in the numbers 6 and 9, our greatest common factor is our groups of 3. So now let's turn that into some numbers. Let's say I have the number 4 and the number 6. What's the largest number that can be divided evenly into both of those? It would be 2. It divides into this one twice and divides into this one 3 times. Let's try some other numbers. How about 16 and 4? Well, my greatest common factor in this case is 4. I can make 4 groups here, and I can make 1 group there. So now let's turn it into a factoring problem. Let's use these same numbers. So let's say I have 4 plus 6. Well, when I take out 2 of each one, I have 2 groups here, so I'd be left with my group of 2, and then my groups over here, which would be 3. And you can see 4 plus 6 is, of course, 10. And if I multiply all this by using the distributive property, I have 2 times 2 is 4, plus 2 times 3, which is 6, and I get the same answer. So this is equal to that. Okay? So now we're going to start adding some variables to that, and my paper is getting more and more messy. I better go to the next page. So let's say we have the number 4x plus 6x. Well, I can take groups of 2 out of each one of those, right? So I put my 2 on the outside. But I could also take out the x from each one. And then inside, I'd be left with, how many groups of 2 go into 4? 2 of them. No x anymore because I already took the x out. And then over here, how many groups of 2 go into 6? There is, of course, 3. And again, no x because I already took the x out. Okay? So then we'd be left with 2x times 2 plus 3. Now, if you actually had that inside, you would, of course, want to simplify it. 2x times 5. Now, let's talk about some other variables. Let's say I have a group of AB and another group of just A. what's the thing I can take out of both of them? The A, right? So in that case, I'd be left with B, and I'd be left with 1. Okay, let's try A squared plus AB. Well, the biggest group I can take out is one of the A's. I can't take out 2 from here because I only have 1. So I'm going to take one of the A's out, and here I would have 1 left. So I have my other A. Here I would already have taken out my A, so that just leaves us with the number 1, which we don't need it, times B. And that's what we're left with. Okay, so let's add some numbers to that. Let's say I have 4A plus 6AB. Well, we have to first find the common factor, the greatest common factor, which in 4 and 6, do you remember? It was 2. And of the letters, what can be taken out? Just the A, right? So if I go back to what would be inside, if I take 2 out of this 4, I have 2 groups left. And I already took out the A, which just leaves a 1, and 2 times 1 is just 2, so I don't need it. And then how many groups of 2 can be taken out of 6? Why, of course, 3. I don't need my A, I've already taken it out. And so what's left is B. Now I can't combine 2 and 3B. I can't do anything with it, so it just has to stay like that. So this ends up being our final answer. Hope that helps, guys.